Black dragonfish. The deep ocean has a rule. No light, no vision, no chance. 2,000 meters down, one fish just broke that rule completely, and everything around it is already dead and doesn't know it yet. The black dragonfish carries a photophore under each eye that fires red light, and almost nothing else down here can see red. Most marine animals rely on blue light, since it's the only wavelength dense enough to travel through deep water. Longer wavelengths like red essentially don't exist at depth, which is exactly why so many deep-sea animals are red. It functions as invisibility. The dragonfish turns that invisibility into a weapon. By emitting red light that gets reabsorbed at close range, it can perceive the otherwise elusive red-colored prey nearby without being detected by them or by larger predators. It's not just producing light. Its retina is enhanced by a rare bacteria chlorophyll-derived photosensitizer, a pigment more associated with photosynthetic bacteria than a vertebrate's eye. Scientists still don't fully know where that pigment even comes from. What they do know is this: every other predator sharing that water is functionally blind to it. The dragonfish isn't hunting in the dark. It built its own private spectrum of light that only it can use, and everything else is prey that never sees it coming. Anglerfish. The lure comes first, always. A soft, glowing bulb dangling in front of a mouth lined with needle teeth, swaying gently in water with zero ambient light. Curious prey drifts toward it, mistaking a predator's face for food. That's the entire hunting strategy of the anglerfish, and it barely needs to move to execute it. But the lure isn't even the strangest part of this animal. Male anglerfish are a fraction of the female size, and in several species, when a male finally finds a mate in the vast emptiness of the deep ocean, he bites into her body and never lets go. Their tissues fuse. His circulatory system merges with hers. He stops being an independent organism and becomes a permanent, parasitic attachment, sometimes reduced to little more than a pair of gonads riding along for reproduction. Finding a mate down here is so rare that evolution didn't build anglerfish to court. It built them to physically weld together the moment they find one, permanently, so the opportunity is never wasted. The lure gets the headlines. The disappearing male is the part that should actually unsettle you. Pacific viperfish. Its teeth are so long they don't fit inside its own mouth. The fangs of the Pacific viperfish curve backward and rest near its eyes, protruding outside the jaw entirely, and closing its mouth fully would mean driving those fangs into its own skull. This fish tops out at around 30 centimeters, hunting at depths between 200 and 1,500 meters where sunlight never reaches. It doesn't need to see well in the traditional sense. A bioluminescent lure at the tip of its dorsal fin swings forward like a fishing rod, flickering to draw prey directly toward its exposed teeth. Once something bites, there's no escaping the impaled position those backward curving fangs create. And its body is built entirely around the strike. A flexible hinge in the first vertebra behaves like a built-in shock absorber, letting the fish launch forward at speed without snapping its own spine on impact. Every part of this animal is a weapon aimed inward at the exact moment of the kill. The teeth, the spine, the lure. It's not built to chase. It's built to stand perfectly still in absolute blackness and let its own body do something no other predator's anatomy allows. Bobbit worm. Nothing about the seafloor looks dangerous, until 5 thin antennae twitch beneath the sand. That's the only visible part of a creature that can be up to 10 feet long, buried entirely in sediment, using its antennae to sense the minute vibrations of anything swimming past. The moment prey crosses that invisible trip line, the response is nearly instant. The strike has been clocked at speeds up to 6 meters per second. From the trigger to the prey disappearing underground takes less time than a human blink. The jaws themselves, called aciculae, are strong enough to cleanly sever prey in half in a single snap. What makes this worse is how old the strategy is. Fossilized burrows matching this exact ambush pattern date back more than 20 million years, meaning this hunting method hasn't needed to change since long before most modern predators existed. It doesn't chase, doesn't stalk, doesn't need eyes. It just waits, feeling for vibration in total darkness, for as long as it takes. The ocean floor isn't empty. It's loaded. Barn owl. Picture total darkness, no moonlight, no stars, nothing. Now picture a rodent rustling through dry leaves 30 feet away, and an owl locking onto its exact position without seeing a single photon of light. In controlled experiments, barn owls housed in complete darkness were still able to capture live rodents moving across dry leaves with pinpoint accuracy. The secret is in the ears, and they're deliberately not symmetrical. One ear opening sits higher than the other on the skull, so sound reaches each ear at a slightly different time, letting the owl rotate its head until the noise lines up equally in both ears, locking in the prey's exact horizontal and vertical position. Owls with symmetrical ears, tested under the same conditions, simply could not be trained to hunt in total darkness. Only the asymmetrical-eared species could. Add in feathers engineered to eliminate the sound of flight entirely, and prey gets no warning at all. This isn't enhanced hearing. It's a targeting system built from mismatched anatomy, precise enough to replace eyesight completely. Ferdinands. Somewhere in the leaf litter of a Central American forest floor, a shape you can't see is already tracking your body heat. The fer-de-lance doesn't need light to hunt. Specialized L'Oreal pits between each eye and nostril detect infrared radiation, picking up thermal contrasts from anything warmer than the surrounding air. That's how it finds warm-blooded prey in pitch darkness with enough precision to strike accurately on the first attempt. A single bite injects around 105 milligrams of venom, while as little as 50 milligrams can be fatal to a human, and this one species alone accounts for nearly half of all snake bites in Costa Rica. The venom isn't quick or clean. It's strongly hemotoxic, triggering rapid swelling, tissue necrosis, and disrupted blood clotting throughout the body. Its range stretches from southern Mexico down through much of South America, and it's known locally by names like terciopelo and barba amarilla, references to its velvet-like skin and yellow-tinged jaw. Juveniles even have a trick adults lose, twitching a brightly colored tail tip to lure frogs and lizards close enough to strike, a behavior called caudal luring. Females can give birth to 60 to 80 live young in a single litter, each one born fully venomous and capable of striking within hours. And most bites aren't the result of the snake hunting a person at all. Its camouflage is so effective on unpaved trails that people simply don't see it and step directly on it. It isn't chasing anyone. It's just extremely good at staying invisible while it waits for something warm to walk by. Leopard cat. Out in the forests of Asia, something is watching you long before your eyes adjust to the dark. The leopard cat is barely the size of a large house cat, but its night vision runs on the same mechanism carried by every serious nocturnal predator, a reflective layer behind the retina called the tapetum lucidum, which bounces light back through the photoreceptors for a second chance at absorption. The effect is powerful enough that cats can function in light levels several times dimmer than what a human eye requires just to register motion. Combined with wide pupils built to flood the eye with whatever light exists, the leopard cat can track a rodent's movement across ground that looks like a flat black void to anything else nearby. This is one of the most widespread wild cats on Earth, found from India through Southeast Asia and up into parts of Russia and Japan, adapting its diet to whatever's available: rodents, birds, insects, even small reptiles. Despite its size, it's a solitary and territorial hunter that avoids other leopard cats outside of breeding season, relying entirely on stealth rather than pack strategy. It's also the wild ancestor behind the Bengal cat breed, meaning that spotted coat sitting on some living room couches traces directly back to this exact nocturnal hunter. It doesn't rely on speed or size to win. It relies on seeing clearly while its prey sees nothing at all. Solitary, silent, and built for the exact hours when most other animals go blind, the leopard cat turns an ordinary night walk into an ambush zone without a single warning sign. Giant huntsman spider. Deep inside a limestone cave in Laos, something with a 30-centimeter leg span is running sideways across the ceiling, and it's faster than almost anything with 8 legs has any right to be. Discovered only in 2001 by German arachnologist Peter Jaeger, the giant huntsman spider holds the record for the largest leg span of any spider on Earth, even though its actual body measures only about 4.6 centimeters. Nearly all of its size comes from those sprawling legs alone. It doesn't build webs. Instead, it actively hunts, using speed and nocturnal timing to chase down insects and other invertebrates in total darkness, and its crab-like sideways scuttle lets it change direction instantly across uneven cave walls at speeds up to 1 meter per second. Its legs are covered in fine sensory hairs that pick up the smallest vibration a fleeing insect can make, letting it track prey it can't even see. This species exists in only one known location on the planet, a cluster of caves in Laos's Khammouan province, and nowhere else has ever recorded it. And the danger doesn't end at the hunt. Females have been documented eating males after mating, a behavior more typical of black widows than huntsman spiders. It's not dangerous to humans. A bite compares to a bee sting at worst. But for anything smaller sharing that cave, in that darkness, it's one of the fastest, most efficient killers on the planet.